This is a presentation brought to you by the Michigan Department of Environmental Quality on the draft operating license proposed to be issued to Dow Corning Corporation for its hazardous waste storage and disposal facility. Dow Corning is located at 3901 South Saginaw Road in the city of Midland in Midland County, Michigan. This facility is identified by the state and federal hazardous waste program under the identification number of MID 000809632. Dow Corning has been a chemical manufacturer of silicon-based materials at this location since 1943. The manufacturing operations are conducted on approximately 350 acres. The DEQ is proposing to reissue an operating license to Dow Corning. The DEQ has drafted the operating license and is making it available for public review. The DEQ has issued operating licenses to Dow Corning in the past on September 29, 1988, September 30th, 1994, and September 29, 2000. The September 29, 2000 operating license remains in effect pursuant to 1969 Public Act 306 as amended, Michigan Administrative Procedures Act, because a timely renewal application was submitted by Dow Corning on March 25, 2010. Also, this allows continued operation until DEQ makes final determination on the renewal application. The draft operating license will allow Dow Corning to manage hazardous waste generated at its Midland plant or at other off-site facilities that are majority owned by Dow Corning and located in the United States. These wastes are off-spec or outdated raw materials, manufacturing byproducts, returned virgin products from their customers, waste from laboratory operations, as well as personal protective equipment, spill cleanup materials, and debris contaminated with these wastes. Hazardous waste may be stored in the 801 or 809 building container storage areas or the 806 tank farm prior to shipment for off-site disposal. The draft operating license also authorizes Dow Corning to landfill D008 lead-based waste, although Dow Corning only disposes of non-hazardous waste in the landfill at this time. The DEQ is proposing to reissue Dow Corning an operating license for a term of 10 years. This license has 8 parts. Part 1 covers requirements that are included in all licenses, such as general requirements to operate the facility in a manner to prevent harm to human health, welfare, or the environment. Part 2 covers requirements such as waste analysis, record keeping, emergency procedures in the event of a release, inspection requirements, financial assurance requirements, and requirements for closing the facility should Dow Corning cease to operate the storage units or the landfill. Parts 3 through 5 of the draft license covers site-specific requirements for storage in containers, tanks, and disposal in the landfill. These requirements include design capacity, storage locations, type of waste to be managed in the unit, and any other requirements to ensure protection of human health and the environment. One of the container storage areas included in the draft license is the 801 building. The 801 building is a 2,748 square foot structure with a sloped roof and enclosed on 3 sides. It will be authorized to store 26,400 gallons of hazardous waste. The maximum number of 55-gallon drums that may be stored in the 801 building is 480. Adequate secondary containment is provided by concrete slab and curbing. The concrete slab is reinforced and coated with a chemical-resistant epoxy coating that is resistant to solvents and most acids and base. This is a view of the 801 container storage building. This is a view of the inside storage configuration of the 801 Container Storage Building. Another container storage area in the draft license is the 809 building. The 809 building is a 5,886 square foot building, including the 384 square foot loading dock annex designated as the 805 building. It will be authorized to store 85,000 gallons of hazardous waste. The maximum number of 55-gallon drums that may be stored in the 809 building is 1,818. Adequate secondary containment is provided by a concrete floor sloped to a channel that leads to the spill pond. The concrete slab is reinforced and coated with a chemical-resistant epoxy coating that is resistant to solvents and most bases and acids. This is a view of the inside of the 809 Container Storage Building. The draft license will authorize storage in the 806 tank farm located in the 800 block of the site. The 806 tank farm will be authorized to store 60,000 gallons of hazardous waste in 6 10,000-gallon steel vertical tanks. The 806 tank farm is provided with a concrete dike and floor with a containment trench around the inside of the containment area that serves as an external liner. All concrete is reinforced and sealed with a chemical-resistant epoxy coating. The concrete containment trench is connected to the spill pond. This is a view of the 806 tank farm. This is a view of the spill pond that serves as a part of the secondary containment system for the 801 and 809 container storage buildings and the 806 tank farm. The spill pond is constructed of clay overlain by a synthetic liner. The spill pond has a total storage capacity of 142,000 gallons. The draft license will authorize a total disposal volume of 453 acre-feet or 731,000 cubic yards for waste exhibiting the characteristic of toxicity for lead D008 and compatible non-hazardous waste. Although Dow Corning wants to retain the ability to dispose of lead-based paint in the landfill, currently they are only disposing of non-hazardous waste in the landfill. This is a view of the landfill. Part 6 of the draft license addresses the environmental monitoring requirements for groundwater, surface water, landfill leachate, and corrective action monitoring. This monitoring program tells us whether any releases have occurred and whether that release is migrating from the facility. Additional information about the specific monitoring programs will be provided later in this presentation. Part 7 of the draft license addresses corrective action. It identifies the waste management units at the facility and their current status. It also identifies the process and requirements for conducting investigation, evaluations, and other actions at the waste management units. Currently, for corrective action, Dow Corning is implementing an interim measure by collecting shallow groundwater through an interceptor trench that surrounds the entire site. The shallow groundwater is collected and pumped to Dow Chemical Wastewater Treatment Plant for treatment prior to discharge to the Tippecanoe River. Part 7 also identifies procedures for notifying the DEQ in case of a release from a waste management unit or the discovery of a new waste management unit. It also identifies procedures for conducting investigation, corrective measure study, and corrective actions for any new releases. The license also includes 13 attachments that identify specific operating and technical information, and this is a list of those attachments.
My name is Joe Rogers. I'm the project geologist for the Dow Corning facility, and I'm going to discuss the environmental monitoring activities for the facility that's required to conduct per its operating license. The purpose of the environmental monitoring is to ensure there are no releases from the facility that could potentially impact human health or the environment. They currently do 3 different types of environmental monitoring, including groundwater monitoring, surface water monitoring, and leachate monitoring. But before I talk about the monitoring, I'm going to preface my discussion with a brief introduction regarding the facility's geology and hydrogeology. This is an aerial photograph of the facility with the area outlined in black is the landfill, and you can see the to the west, the Saginaw Avenue and the Tittabawassee River, and the area outlined in green is Lingle Drain. This slide shows a generalized stratigraphic section of the geology underlying the site. In general, the geology consists of underlying sediments overlying bedrock, and the section you see there goes from oldest bedrocks at the bottom to the youngest, surface sand on the top. The unconsolidated sediments are glacial in origin and consist of sand, gravel, and clay. Bedrock is sandstone and shale. The bedrock is a Saginaw Formation. Bedrock on the site has a significant amount of relief. Depth of bedrock varies by more than 200 feet across the site. And where depth of bedrock is deeper, there's obviously more unconsolidated sediments present, and vice versa. And then above the bedrock is the regional aquifer, which is a sand and gravel unit capable of yielding significant amounts of water, and this is monitored as the uppermost aquifer when we do our groundwater monitoring. And the thickness of that unit is variable depending on the depth of bedrock. And then above the regional aquifer is a glacial till, which is mainly impermeable clay with some sand within it. And the thickness, again, is somewhat variable. And then above the till is lake bed clay, which is a relatively impermeable clay, and it's continuous across the site. And this unit, in combination with the glacial till, which is also mainly impermeable clay, form a protective barrier over the regional aquifer for downward migration. And then on top of the clay is the surface sand, which is relatively thin and a discontinuous sand layer, and not really capable of yielding significant amounts of water, but we do some monitoring of that unit. This slide is somewhat difficult to read, but it's a topographic map of the bedrock elevation under the site, and it illustrates the amount of relief under the site. You can see that some of the contours there, the highest contour is 500 feet. That's the high point of the bedrock, and it kind of showed trends to the northeast, and that's sort of a ridge that goes underneath the facility, and you'll see that in future slides when I do some cross sections. This slide shows the facility, and it gives the location of a couple cross sections that I'm going to show in the next couple slides. One going from the northeast to the southwest, and the other one going from the northwest to the southeast. This is the cross section from the southwest to the northeast, and on the top you can see the sand, and then the next unit down is the clay, and then the glacial till, and then the sand and gravel regional aquifer, and then finally the bedrock at the bottom. And you can kind of see as you go to the northeast that the bedrock gets higher in elevation, and that's that ridge that I was talking about. And the sand and gravel is also on a slope, and that's the unit that we're monitoring with the deep monitoring wells. This slide is another cross section, this one going from the northwest to the southeast, and similarly constructed. You can see the ridge again on the north side where the bedrock is a lot higher and the till is a lot thicker, and also as you go to the south, the regional aquifer gets a little bit thicker as well. Now I'm going to talk about the groundwater monitoring that we do as part of the license. There are basically 3 different types of groundwater monitoring that we do. One is a detection monitoring program, one is a supplemental monitoring program, and one is a corrective action monitoring program. The detection monitoring program is conducted in the regional aquifer, as I mentioned before, defined as the uppermost aquifer, and its purpose is to detect a potential release from the landfill. We also do supplemental monitoring in the superficial sand around the landfill, monitoring the uppermost superficial sand unit, which isn't defined as an aquifer, but we do monitoring, and the purpose of that is to track groundwater quality in that shallow groundwater. And then we also do corrective action monitoring at 3 different areas of the facility where releases have occurred previously,
and I'm going to talk about these a little bit more in detail later, but these include the site-wide interceptor system, and then monitoring around the former 604 vaults and monitoring around the former quench ponds. And the purpose of this corrective action monitoring is to track groundwater quality in the shallow groundwater in each of these areas where corrective action is being performed. This is a figure that shows the direction of groundwater flow in the regional aquifer, and you can see by the contours that the flow is to the northwest in the northern part of the facility and to the southwest in the southern part of the facility, and the flow in the regional aquifer is controlled kind of by the thickness of that sand and gravel aquifer, which is in turn controlled by the elevation of the bedrock. A flow moving from the thinner parts of the regional aquifer where the bedrock is higher to the thicker parts where the bedrock is lower. This figure shows the locations of the deep regional aquifer monitoring wells that are monitored. We have 4 down gradient wells which are on the north and one kind of on the northwest corner. Those are DMW 4A, 6A, 10, and 12, and then 2 sort of up gradient wells which are one's located on the south side, 11, and then 9, which is the one that is in the far southwestern part of the slide. So for the detection monitoring program, again, there's 6 monitoring wells screened in the regional aquifer, and these wells are sampled semi-annually for primary, secondary, and tracking parameters. Primary monitoring parameters for the detection monitoring program include several volatile organic compounds that are present in the leachate at elevated concentrations that are good indicators of a potential release. These include benzene, chlorobenzene, ethylbenzene, toluene, 2-methylphenol, and lead. And the secondary monitoring parameters include phenols, arsenic, barium, cadmium, mercury, copper, and zinc. These are also present in the leachate, but they're also naturally occurring, so these have to be evaluated statistically to determine if there's a release. And then we also monitor a lot of general water quality parameters as an indication of a potential release. These include pH, conductivity, total organic carbon, calcium, sodium, magnesium, potassium, chloride, sulfate, and alkalinity. This slide talks about the statistical evaluation of the data after it's collected. For the primary parameters, those are not naturally occurring, so if they're detected, then it's a statistically significant increase. The secondary tracking parameters, as I mentioned, those were naturally occurring, so there's some statistical comparison of each value that's detected at a given event against its historical background to determine if it's increased significantly. And then for either one of the primary or secondary, if we do find a statistically significant exceedance, then resampling in quadruplicate is required for confirmation. And statistics are not performed on the tracking parameters. So if a exceedance is detected in either the primary or secondary monitoring parameters I mentioned, we do confirmation sampling. And if 2 of the 4 resamples, it's done in quadruplicate, detect the compound, then it's determined to be a confirmed exceedance. Or if one of the samples comes in at greater than 5 times the detection limit, then the exceedance is confirmed. So if the exceedance is not confirmed, then we go back to regular detection monitoring. But if the exceedance is confirmed, then that presumes that the reason of the exceedance was because of a potential release from the facility. So the facility is required to investigate potential causes of the release and provide a report within 60 days. Now I'm going to talk about groundwater monitoring in the superficial sand. It's the supplemental monitoring in the superficial sand. This figure here shows the groundwater flow in the superficial sand, and as shown in the figure, the direction is somewhat variable, probably north and east of the facility. The landfill is adjacent to the lingual drain, and flow is likely towards the drain, the surface water feature, and then on the south and west of the landfill, it's probably controlled by the groundwater collection tile that are surrounding the landfill. This figure shows the locations of the monitoring wells that are part of the supplemental monitoring in the superficial sand. There's 8 of them around the landfill, basically 2 on each side, although the north side kind of has 3. There's one kind of right in the northeast corner that's kind of functions on both the north and the east side. The 8 superficial sand shallow monitoring wells are sampled on a semi-annual frequency, and the analytical parameters include general parameters, pH and specific conductivity, major ions, calcium, sodium, magnesium, potassium, chloride, sulfate, and alkalinity, and some additional trace parameters, lead, total phenols, toluene, benzene, ethylbenzene, and chlorobenzene. The shallow groundwater in the surface sand unit has been impacted from historical activities and is being addressed as part of on-site corrective action. I'm going to talk about that in a minute, but as I mentioned before, the purpose of this data is to kind of track the concentrations in the shallow sand, and so a statistical evaluation of the data is not required. The data is just kind of used to track the water quality and do trends over time to determine if any changes are occurring, and if so, to investigate those. And reporting, just like the detection monitoring program, the reporting of the data is required 60 days after the sampling event, and then they also have a detailed annual report required. And I'm going to talk about the corrective action groundwater monitoring. As I mentioned previously, it's required to be conducted in 3 areas of the facility: the site-wide interceptor system, the former 604 vaults, and the former quench ponds. And I'm going to talk about each one in more detail in the following slides. The first corrective action monitoring program I'm going to talk about is the SIS, which is the Site-Wide Interceptor System, known as SIS for short. It's basically a horizontal collection pipe, French drain if you will, installed at the base of the shallow sand unit around the perimeter of a property. It was installed due to previously documented releases to the shallow groundwater from historical activities at the Dow Corning facility, and it was designed and implemented to collect shallow groundwater and eliminate any potential for off-site migration of potentially contaminated shallow groundwater. It was construction was completed in 1998 and was implemented as an interim corrective action. The location of the SIS is shown on the figure there as the red line that goes all around the perimeter of the site. And in the southwest corner you can see the lift station where samples are collected for analytical monitoring, which I'm going to talk about a little bit more in future slides. And from that lift station, the groundwater is pumped to Dow Chemical's wastewater treatment plant for treatment. In addition to the analytical monitoring that I'm going to talk about a little bit more in the next couple of slides, the facility is also required to do quarterly hydraulic monitoring at the SIS in the SIS system at 10 different locations to make sure that inward gradient is maintained and the system is effective in capturing shallow groundwater. This is done by measuring the elevation of the groundwater in the system as well as at points on either side of it to make sure that the system is lower and is capturing potentially contaminated groundwater. If an outward gradient were ever to be detected at this point in its existence, never been detected, but if one were to be detected, the facility would be required to do an additional monitoring event to confirm that there wasn't a mistake, make sure that that was happening, and then if the outward gradient was confirmed, then the facility would have to do an investigation, figure out what was happening, repair the condition to an inward gradient, and then investigate if there was any potential contaminated groundwater migrating off-site, and if so, remediate that. Chemical monitoring of the SIS is done on a quarterly frequency at the SIS lift station, and the detection monitoring parameters, as well as parameters detected in shallow groundwater, are monitored for in order to track and monitor conditions in the groundwater being captured by the SIS. In addition to this quarterly monitoring, there's also extensive monitoring done every 2 years for the RCRA Appendix 9 parameter list, which is a very comprehensive list of monitoring parameters. And the reason this is done is to also to track and monitor conditions, but also see if there's any new contaminants being captured by the SIS that weren't known about previously. Now I'm going to talk about the corrective action monitoring program for the former 604 vaults and the former quench pond. Both of those locations are shown on this figure. The 604 vaults are below concrete grade vaults, about 13 to 15.5 foot deep, that were used to formerly used to house process equipment, and documented releases of chlorinated hydrocarbons from these former processes were previously documented. These compounds include carbon tetrachloride, chloroform, 1,2-dichloroethene, 1,4-dichlorobenzene, 1,3-dichloropropane, and toluene. So each vault has a French drain installed around its perimeter at the shallow sand and clay interface. And the quench ponds were formerly used to neutralize corrosive chlorosilanes using lime, and a major byproduct of this operation was brine that was disposed of in the wastewater sewer, but some brine was released to the environment as part of this operation. Chloride is a major component of the brine, and it was documented to be present in shallow groundwater adjacent to the quench ponds. Now I'm going to talk about the analytical monitoring that's done for both the 604 vault and quench pond corrective action monitoring. The 604 vaults, those were the chlorinated hydrocarbon release. Semi-annual monitoring is done at 3 locations, basically at each French drain that's around each vault, for 8 volatile organic compounds that were known to be released from the former vaults. And those French drains are also currently have French drains installed to collect and control groundwater impacted by the 604 vaults. For the quench pond monitoring, we do annual monitoring for chloride at 3 monitoring wells in the area known to be impacted by the chloride from the release. And the purpose of both these monitoring programs is just to track the concentrations in groundwater of the released compounds. As I mentioned previously, the SIS is a perimeter-wide system, so there's no potential for any of this groundwater from these 2 areas to get off-site, even if it moves away from these areas of known contamination. But we do keep an eye on the concentrations there to make sure they're not worsening significantly. We're now going to talk about the surface water monitoring that is done as part of the license. This figure shows the 3 locations where samples are collected. There is 2 kind of upstream. One is the City of Midland's treatment plant outfall, and there's also one just as the Lingle Drain comes onto Dow Corning's property. And then there's a down gradient location shown there just south of the landfill. So the samples from the 3 locations are sampled on a quarterly frequency, and they're sampled in duplicate. The parameters analyzed in the quarterly sampling of surface water include volatile organic compounds, several volatile organic compounds analyzed by US EPA method 8260, 2,4-dimethylphenol, calcium, sodium, potassium, magnesium, chloride, sulfate, alkalinity, lead, and pH. And reporting on this monitoring is required within 60 days of sampling. After the samples are collected and analyzed, the data is evaluated statistically to determine if there is a potential release by looking at the downstream data versus the upstream data and determining if it's significantly higher, significant meaning more than 3 standard deviations greater than the background concentrations. And if an increase in concentration is detected in the sample, then the duplicate samples that were collected at the same time as the original samples are analyzed for the purposes of confirming whether or not this increase is present. And if the increase is not confirmed, then the existing monitoring program is continued, the quarterly monitoring. If the increase is confirmed, then that requires an investigation into the cause and corrective action if necessary. The final monitoring I'm going to talk about is the leachate monitoring program. Leachate is the liquid that is present inside the landfill cell that is contaminated, obviously, because it's in contact with the waste, and it is collected in a sump in the southwest corner of the facility as shown on this figure. Leachate is analyzed quarterly for pH, lead, mercury, PCBs, and additional organic parameters. And then once every 2 years, it is monitored for a very extensive RCRA Appendix 9 parameter list. The purpose of this monitoring is to determine if there are any new contaminants detected at greater than 0.5 milligrams per liter, and if they are, that's showing that they're kind of a significant contaminant in the leachate, and then they're added to the groundwater monitoring lists and surface water monitoring lists, etc. And then similar to the groundwater and the surface water, an annual report is required on the leachate that details both the analytical chemistry trends and the volume collected. In summary, the facility has been in compliance with the environmental monitoring requirements of the previous hazardous waste management license, and no indications of release from the landfill during the previous license were shown with all the monitoring.
The DEQ is seeking public input on the draft license until August 29, 2012. Please submit written comments, requests to be placed on the facility mailing list, and all other requests for information to Kimberly Tyson, Resource Management Division, Department of Environmental Quality, P.O. Box 30241, Lansing, Michigan 48909, or by email at tysonk@michigan.gov. If you are providing comments on the draft license, please provide your contact information so you can be added to the facility's mailing list. Before issuing a final decision, the DEQ will evaluate all comments received. The final decision will be communicated to all persons on the facility mailing list. This concludes our presentation on the Dow Corning facility and the proposed draft operating license. Thank you for viewing this presentation.